Hello everyone. So today is the 12th class, and today, like I said in the last class, that today I will mostly deal with the ordinary differential equation, and today I will show you the application in Matlab. Okay, so let's start. So, so I have selected a few examples. So the first, so I will deal with both the first order differential equation and the second order differential equation. So so first the first example. So let me share my screen from my tab. Okay, this is the example. So x dot equal to ax minus bx square. So this is so what does it mean where a and b both are greater than zero? Okay. So, suppose if b is not there, so this is called a population growth model. Population growth model. Now suppose when b equal to 0, you all know what is the solution of this. The x equal to what? X equal to x dot equal to x. It is x equal to some constant c into e to the power of a of t. Okay, that means that the population grows exponentially. Now there is another term which is minus b of x square. Okay, now if you differentiate it, you will see that if a is 0 and if you differentiate it, you will see some curve like that. It is for x dot equal to ax and x dot equal to minus b x square. Okay, now when both of them are combined, okay, x dot equal to ax minus bx square, it is called the birth rate. It is called the death rate. So there can be various conditions that are possible. One possible condition will be it will grow and it may saturate. Otherwise it will initially grow, then it will decay. Okay. Now we will try to verify this using Matlab. We will vary this a and b, these two parameters. Okay. Now, like in the last class that I have told that I will use one inbuilt function that is called ODE45. Okay, so this is a very powerful tool for solving ODEs. Okay, this is a very powerful tool that time to time you need to use this. So first I will show you some 7 to 8 examples. I will give you some background of those, and then we will solve those in MATLAB. Then and after that I will solve some theory problem which is related to your assignment work that I will do after that. So let me share my MATLAB screen once again. So Okay. Now let me solve the first problem, that is the population growth problem. Okay. So now first I need to have defined a function. Okay, so let me define the function at the bottom. F equal to at the rate p comma x, because there are two variables where dx dt equal to ax minus bx square. Okay. Just a moment. It is not necessary. Yeah. But I need to define what is A and what is B. Let first try with 0.5 and B is again equal to 0.5. Okay. Now let me tell you a little bit about the ODE 45. So you have to write in this format. One is T, sorry, yeah, T and some output. Maybe the output result is X of A. Okay, equal to ODE 45. So it will give you two column vector. One will correspond to T and other will correspond to X of A. If, comma, there will be some T span. I will tell about T span and X naught. Now, what is T span? Suppose you want your result to be, suppose you want your result at from t equal to 0 to t equal to 30. That you need to mention in T span, and X naught is your initial condition. And remember that you need to write everything in this format. Okay, because this is inbuilt in Matlab, so you have to remember that. So T span equal to 0 and maybe 10. Okay, 0 to 10, and x naught is initial population, let me take as 1. So before running, so now I need to plot the result with respect to time. So plot e comma x of a. So I can now run the code. So before that I need to save it. So it is class 12 live session. Okay, just a moment. So it is giving a straight line. Why? T is 41 into 1 double. X is same. Okay. So maybe just a moment. Let me take some other variable. Population ODE to 30. 1 point. Okay. Let me take this. Equal to, equal to 3 into 1.3 and T is 10. So now you can see the result. Okay. So here my a equal to 2 3 and b equal to 2.3, and t span is 0 to 30. Now remember one interesting thing. Here t span is a 2 cross is a 1 cross 2 vector. Okay, so this is a row vector. So here is 0 is the initial time and 30 is the final time. Now you go to I think, can you see this? Here if I just write x of a and this x of a and t, these two are my output result, output t and output xa. So if I just write length of t, it is giving 117. Okay, so that means that although I have provided only just 2 points, 0 and 30, MATLAB internally has calculated some dt. If you check it, you will find that this dt is not uniform. This is a non-uniform dt, which makes this OD45 so much powerful. So that, and which length is 117. Now suppose I change this my t span. Suppose I want my result at at a unit time step. So 0 to 1 to 30. I have defined my t-span in this manner. Now let's see what will be the result. Yeah. Now if I just write length of t, its length is 31, which is same as t-span. So the take-home message is, if you do not, there may be possibility that you need your result at some particular points. In those cases, you can mention t-span in this way. Otherwise, just 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 do this. Just provide it the initial condition and the initial time and the final time, and MATLAB will do the rest for you. Yeah. Okay. Now suppose if I change my the parameter value a or b. Suppose if I change it to maybe 3.3. So you can see that it decays sharply. Now if I make it smaller, maybe 0.1. So you can see that it initially grows, and after that there are minor oscillation, which there are some minor oscillation, but more or less it is almost stable. It reaches to almost this 30 value. Okay, it reaches 29.997. It reaches almost there. Okay, but there will be some okay, just a moment. But there will be some parameter value where you can see those oscillations, like I showed in the first plot. Okay, now we can move on to the next example. Just a moment. Yeah. So now we can move on to the next example. Okay, so let me check what is the second example that I have selected. Set. Okay. Um, So let me share my tab screen. All right. Now the second example is to dx dt plus 3 plus sine 2t x equal to, if sine 2t is not there, then you will have dx dt equal to minus 3 of x equal to x naught e to the power minus 3 of t. So it will be some. So sine 2t is an oscillatory function like this from 0. So after 3, this is suppose 3, it will do some kind of oscillate. We will not get a simply exponential curve like this. We should get something like this. It will oscillate and it will continue to decay. Okay. So now let's check that. Let me unshare this so you can see the MATLAB screen clearly. Okay. So, okay, I can now remove this. Okay. So just a moment. So now this example is um, so so here let me write the function f equal to at the rate t comma x. Okay, and the function is 3 plus sine 2t, right? So minus of 3 plus sine of star t. Now let me tell. So I shouldn't write it if. Let me write it dx dt. Now the original equation was dx dt plus 3 plus sine 2t equal to the dx dt plus 3 plus sine 2t equal to 0. So if I take it to the right hand side, it will be minus 3 plus sine 2t. Okay. So let me take the initial guess x naught at 1 and let try t span with 0 to 1. Now the result p x a. You can give any variable. It is not like we have mentioned previously t n x, so you cannot write t n x. You can write t n x and it will be modified automatically. So t of x equal to O D E 4 5 dx dt is n and x naught. So you can just plot e comma x, and I think it should work. Okay, so it is just showing a straight line. So maybe what we can do, we can maybe take the limit to 10 maybe. So a little bit of oscillation is showing. Now increase the limit even further, maybe 50. Yeah. So you can see that little bit of oscillation is present. Okay, the oscillation is present, but it is decaying. Okay, it is a continuously decaying function. Okay. So now let's move on to the third example. Okay, so just a moment. Huh? So now, so previously the Matlab screen was not recording. So now I have changed it. Okay, now it should do. So okay, so so, let's move on to the next example. So what does the next example say? So now it will be example 3. Right. So now this now okay. So now for the first time we will talk about the second order. So these two were the first order differential equation. Now we will talk about the second order differential equation. Okay. So let me share my tab screen again. Right. So now the example is no, not this one. Pardon. Huh. So it is 1 plus t square d square w dt square plus 3t dw dt plus 2w equal to 4. Okay. Now we need to solve this using OD45. Now we cannot solve any problem in numerical computation directly, which is in this form. The numerical computation only differentiation, sorry, numerical OD only works for this kind of thing. Dx dt equal to f of x t, which we have discussed in the last class. Okay. So now we need to convert this equation to this form. Only then we can proceed. So how to do that? So let us define another variable z. Let us define z equal to dw dt. So this is one equation. And the second equation would be 1 plus t square dz dt plus 3t z plus 2w equal to 4, which imply, so I need a form like this, like dx dt equal to f of x t. So it will be dz dt equal to 4 minus 2w minus 2 3tz 1 plus t square. Okay, so I need to write in this manner. So in order to do that, so let me go to the this right. So let us define a function separately. Dx dt equal to function live session e comma x. Okay, this is how you define a function in MATLAB. So now directly we can directly write a final form dx dt. So the first, so the first thing was dx dt equal to, the first one was the dw dt equal to z. Okay, z means, so x of 2. Let me just finish writing, then I will explain. 4 minus 2 times 2 times x of 1 minus 3 times t times x of 2 divided by 1 plus b square. Now, in this example, now here, unlike the previous two examples, this is here x is a vector, okay, and I am defining my z as x of 2 and my or w as x of 1. Okay, x1 is w and x2 is z. So that means dw dt equal to z, which means the first for the first one appear in this column vector will be x of 2. So I can write this in this format. So I can now save this. Dx dt equal to function. Just a second. Right. So let me just save it. Function live session dot m. Okay. Yeah. So now we are ready. So I don't need it now. Okay. So here x naught is a vector. So I need to specify the initial I need to specify w of 0 and z of 0. Suppose w of 0 is 1 and z of 0 is 0.5. 0.5. Span, let us take 0 to 5. Okay. Now tx equal to ODE 45. Now I cannot write dx dt. I need to write the function name. You need to call the function in this way, at the rate function live. Just a moment, my computer is connecting. Yeah, so function live session p span x naught and plot px. So let's see. Okay, now I cannot write p of x like this. So here x is a vector. So I need to specify p comma colon x of 1 hold on dot p comma x colon 2. Yeah. So this blue one corresponds to x of 1 and this orange one corresponds to x of 2. Okay. Now you can see here x appears as 49 into 2 column vector. This first column corresponds to w and the second column corresponds to z. Now there is another plot that we can do from here. We can plot w versus z. That is called phase portrait. I will talk about this phase portrait in a moment. Yeah. So this is the phase portrait. This is the horizontal axis is z and the vertical axis is z. Okay. We can increase the time maybe. Let us check. Maybe 50. Let's see, but it does. Yeah. So it initially increases, then comes back. It does something like that. Okay. So now let us move on to the next example. Okay. Now the next example. Going to the fourth. So now this problem is related. This problem is a simple pendulum problem. Okay. Now the equation for the pendulum motion is d2x dt square plus some constant. Okay, omega square sine of x equal to 0. This is the equation for the pendulum. Now we assume, so in our school we always assume that this angle theta, here I have mentioned it at x, theta is much small, very small. Okay, so we can always assume the sine theta is approximately equal to theta, so which makes this problem very easy. It will become d2x dt square plus omega square of x equal to 0. Okay, so now we can solve this problem. So first I will show you how the phase portrait of this plot looks like. Then I will show how the phase portrait of the original pendulum, that is omega square into sine x, looks like. Okay, so let's do that. Let me stop sharing the screen. Okay. So we will solve the linear pendulum problem. Okay, so
Hello, sir.
first I need. Hi, hello.
Sir, actually, I have one doubt. I think in portal, in Swayam NPTEL portal, I think you uploaded the solution for first 4 weeks only, right?
Sorry, yeah, you are not audible.
For assignment solution, I'm asking.
Huh?
Yeah, just a minute, sir. Just a minute. Just a minute, sir. Hello, sir. Can you able to hear me now? Hello. Hello.
Yes. Hi, yes, I can hear you. Yes, I can hear you. Hello.
Yes, sir. Yes, sir. Yes, sir. I think some lag. It seems.
अच्छा, okay. Yes, what are you saying? Hello?
Hello.
Yes.
Yeah, can you able to hear me now, sir?
Yes, yes. Yes,
Yeah,
I
okay,
can hear
fine.
you.
Yeah, yeah, sir. Sir, actually, in Swayam portal, I think you
Huh?
uploaded the solution for only 4 weeks, right? For assignment solution.
Each week I
Assignments.
have uploaded the solution. Huh?
I
No, no, no.
think you
No,
uploaded.
no, no, no. Sorry, sorry, sorry. I do not upload the assignment solution. The assignment solution will
Okay.
be uploaded by other TS. I will just take live session, and what I do in the live session, I just post them. You can see there is some Google folder link in NPTEL where you can find all the documents, not assignment solutions.
Okay, okay, sir. Okay, fine. Actually, that's my doubt. We did the assignment and everything. Some question we got a correct answer. Some question
No,
we
no,
got a wrong answer.
I do
So,
not do the assignment solution. No,
okay, to
there are some.
whom should I contact for this? For this,
there
to whom
there
should
will
I?
be there will be some other tests that is which are taking who are taking the course. Actually, I do not have there is another T and me who are just conducting this live session. Not We are not dealing with the assignments. So you can ask
Okay,
in
sir.
the
No issues.
you can ask
Sure,
in the
sure, sure,
group
sir.
also.
I will contact them. If possible, can you please post their mail ID or something in chat box, please?
Okay, 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 sure, sure.
Yeah, please post me in chat box. I will contact them.
Huh, huh.
Then one more
Okay.
thing, sir. One more doubt I have. Do you have any idea about answer final exam pattern?
No,
It will be
no
like
exam.
yeah, it will be like objective only. Is there any like
No,
it's full
no.
of on?
They have shared something. I think. I mean, I do not have any idea. I mean, what will be the exam pattern? Because we are not
No,
in
no, sir. They
direct contact with the course instructor. We are just taking the live session. I am also doing the course like you. I mean, I have done it previously, so I am taking just the live session. If you have any doubt regarding the assignments or regarding the course, not
okay, sir. Okay,
entirely
fine.
related to the exam pattern or anything. Hmm.
Okay, okay, fine, sir. Okay, then so last year you took this exam, right? How was the pattern? It's
No,
only
no, no,
of
no.
1 mark or
I
two
did
mark
not.
kind of things.
I did not apply for the exam. I mean, I just did it in Swayam portal, but I didn't go for the exam. I just took the
Okay, sir.
course
Fine. No
for me,
issues. No
not
issues.
for the
No
exam.
issues. No issues. No issues. Okay, fine.
Okay,
Okay, fine. You
okay.
can please share me the mail ID of the people to whom should I contact for assignment solution, please.
It is better if you post in the Google form because I do not also know I don't know their name as well. So you can directly contact the NPTEL team or write in the Google form. But I only know that if you have because if I have any query, I will also write in the Google forum.
No issues, sir. No issues because so long weeks before I posted in a Google form. So after a
Ah,
long time, we got a solution for only 4 week assignment. So that only I asked. Okay.
acha,
Anyway,
acha.
the remaining 8 week, the remaining if 8 week, if you post it means it's very helpful for it's very helpful to rectify our errors, or else we blindly go for exam. So that I asked.
Okay,
I posted it long before I posted, and every week you given a feedback form, right? That's what also I felt. No issues, sir. No issues. I will post it again.
okay, okay.
Okay, okay, fine.
So let me continue again.
Okay. If possible, can you please suggest some textbook for this course?
Takes two. I think doing the course itself is sufficient for this.
Okay, fine. Okay, fine. Okay, then. No issues. Thank you.
Okay. So okay. So now I need to write the uh, linear pendulum problem. Okay. So the okay, so the idea is same. It is a second order differential equation, and you need to convert it to the two first order differential equation. So the first one will be my x of two, and the second one will be minus omega square of x one. So maybe minus four times x of one. Okay. So this is the thing. So let me just save it, and okay, let's go back to this case. Now. Uh, Okay, so I don't have much time, so let me just directly copy paste it from this. Yeah, so I will tell you what I have done, or maybe I can tell you here. So this fourth example is the exactly same as the exactly the same function. So what I have done is here I have taken here I have taken some range. Okay, this x and v indicate the initial condition. X indicates the initial position, and v indicate the initial velocity. So it starts from minus 5, then it is minus 4.5. So I have taken many initial conditions. Similarly, same as this v. Oh, just a moment. Huh? Yeah. So here t span is 0 to 50. Now here, as I have many initial conditions, so I am taking it inside a loop. Here x naught here I am deciding x naught in this manner. Okay, it will take each x naught, and it will just do this calculation. So that you need to write the function, it will call the function t span x naught is already provided, and I am plotting the what is this? This is I am plotting the phase portrait. Okay. Now let me just run this, and you will see. Yeah. So you can see that I have taken many initial conditions, and for each initial condition I am getting a circle. Okay, this is the phase portrait for the uh, linear pendulum. So I can take now v equal to minus x. Now you will change this. Will The phase portrait will change. Yeah. Now this is the phase portrait when v equal to minus x. You can see all concentric circles. Now, now if I change it to sine of x, the original pendulum equation, in this thing, I need to change it with sine of x1. Sine. Okay. Now you will see that everything will change. Yeah. So it is a little difficult to see, but I will show you. You can see that there are some after that the shape distort. Its shape is distorted, and above and over that there are some wavy kind of pattern. You will see this instead of the x of 1, I have considered sine of x1, and everything changes. Okay, so I will not go into detail of why this happens, but just for your enjoyment. Now let me go to the fifth example. So here I will deal with three variables. Okay, just let me just quickly write you the equations. So it is now equation 5. Okay, so here I have three variables. Okay, x, y, and z. Dx dt is equal to 10 times x minus y. Sorry, 10y minus x dy dt is x into 28 minus z, and dz dt is equal to xy minus 8 by 3 and z. Okay, so I need to solve these three initial condition. So here what I have done, instead of just plot this thing, I have here I have done an animation. For that I have used the comment comet 3. If I have two variable, then you need to write as comet, simply comet. Okay, so what this comet thing does. So suppose if you have some x data and y data, it will plot some curve like this. And if you just do plot x and y, now if you do comet x and y, then it will show you the entire journey. That means it starts from here, then it will go there, then it will go there. So it will show you a dot, and it will just move like this. Okay, and it will show you the entire steps of doing this plot. Okay, this is what comet does. So let me unshare my tab screen. Okay. Yeah. So yes. So here is that example. Okay. There is simple four line code. So okay. So here I am defining my figure size. This is necessary just to visualize the animation clearly. Okay. So and this is the function what I have already written. Now there are three variables x, y, and z. So at x naught, I need to provide three initial condition. So at x0 equal to 0, x1 x2 equal to half, and x1 equal to 0, x2 equal to half, and x3 equal to 3. And now if I can just play it. Yeah. So you can see that it is doing the entire step. All this thing is happening by just from this whole line of codes. Okay. And all of this, it is not solvable analytically, so you need to use ODE 45 to do that. So now I think the idea is clear. Now I can go to the next example. Just hold on a moment, I will be back in a minute. Okay. So now I will quickly show you the next example. So this is also, that is also uh, three variable problems. Okay. I will share you all the codes and you can see the equations. So now let me just, idea is same, only the governing equation is different. Okay. So let me just play it for you. Okay. So now it is already 8. So now I will do some theory problem. So let me stop share the screen. Okay. So right. So now just a moment. So now right. So the first question. So you need to solve it using the Adam-Bashmore technique. Okay. So let me write the formula for you. The calculation is very straightforward, but it is a bit lengthy. So 1 n p, p is the predictor term, equal to yn plus h by 24 yn prime, and yn plus 1 c. This is the correct term. is yn plus h by 24 p prime plus 19 yn prime minus 5 yn minus 1 prime plus yn minus 2. Now from the equation from the question you can see that y 0.1 equal to 1.01, y 0.2 is equal to 0.022, y 0.3 is equal to 1.023, and y 0 equal to 1. And you need to find the value at y at 0.4 using this technique. So here the solution for p equal to y 0.4 plus h by 24. You can see that h will be 0.1, 55 y 0.3 prime, that is yn prime. Okay, just a point before, just a point uh, before that, minus 59 y 0.2 prime plus 37 y 0.1 prime minus 9 y prime of 0. Now, how to get this result? Y prime of 0. You need to find this result from here. This is your y prime of x, xy by 2. So, y prime of 0, if you calculate it, it will get 1 into 0 by 2 equal to 0. Y prime 0.1 is 1.01 into 1.01 is the y already provided, and this is x. 0.1 by 2 equal to 0.0505 y prime 0.2. So I am writing the answer directly. It will be, just do it. You will find it will be 0.1022, and y prime 0.3, it will be 0.15345. Okay. Now first we need to calculate a predictor term y 0.4 at predictor. It will be 1.023, that is y of 0.3 yn plus h is 0.1, which is evident, by 24 by into 55 into yn prime, that is 55 into y 0.3 prime, and we have already got that answer into 0.15345 minus 59 into 0.1022, that is yn minus 1 prime, plus 37 into 0.0505, that is yn minus 2 prime, that is y 0.1 prime, this term, and minus yn 9 into yn minus 3 prime, that is y 0 prime, and that is 0. So if you do the calculation, so I have already done it. If you do the calculation, you will see that the result is 1.0408. Now there is one more step left. That is the corrector term. Same thing we need to do. It will be equal to y 0.3 plus a. So we just need to do one more new calculation. That is finding this term. Other prime values we have already got them. This we need to find. So it will be 9 into yp y prime yp 0.4 plus 19 y prime 0.3 minus 5 into y prime 0.2 plus y prime of 0.1. Remember that in the corrector term it doesn't end with yn minus 3, it ends with yn minus 2. Okay, so the answer will be 1.023 plus 0.1 by 24. We need to calculate this. It will be 9 into 0.4 into 1.0408, which is this term divided by 2 plus 19 into 0.15345 minus 5 into 0.1022 plus 0.0505. And if you do the calculation, you will find that the final answer is 1.041. Okay, so this will be your final result. Now, again, a similar problem for your practice. So here, the idea is same. You need to find the answer at y 1.4 using the same method, same formula, and these things are provided to you, and the function is different. Okay, so you can very simply write a code and do this, but here let's do it by hand. So, so I am not writing the entire formula once again. So let me just write y0 prime. Y0 prime is 1 into 1 plus 1 because these values are provided. Huh? Y h equal to 1, 0.1. I need to find y4p and y4c, right? This is my y0, this is y1, y2, and y3. Okay, the y0 prime equal to 2, y1 prime equal to 1.1 square. Remember the function is this is the function y prime equal to x square into 1 plus y, 0.1 square into 1 plus 1.233 will give you 2.7019. Similarly, we will get y2 prime because the 3.6691. The problem is exactly same, so I am not doing the entire calculation. And y3 prime will be y 5.0345. Now, if you do the calculation, I am just writing the key steps. It will be 1.979 plus 0.1 by 24, 55 into 0. 0.6691 plus 37 into 2.7019 minus 9 into 2. So your final answer will be in this way 2.5723. Okay. Now the new thing will be you need to find y4p prime. What is the value? You will find that 1.4 square, that is the x square, into 1 plus y4p, that is 2.5723. You will get the answer is 7.003. Now you plug in the formula of the corrector term, and finally you will get the result as 2.5637. This will be your correct answer. All right. So now few MCQ questions. So this problem is regarding the linear multi-step method. Here it is told that you need to find the correct option. Okay. So this is the first option, that is summation j equal to 0 to k. First option is j equal to 0 to k alpha j xij equal to h summation j equal to 0 to k beta j f of I plus j. Okay. Now see, now the second, now you see that these two options, in the third option there is no h, so there should be one h, so obviously this option is not correct. Okay. In the second option, it selectively takes some points of x. Okay, 2i plus 2j, that is even point, but that is not true, so this option is not can be true. But here you can see that this is a good definition for the good definition for LML. So this is the correct answer. So option A is correct in this question. Now another conceptual question: a multi-step method is said to be convergent if it is only if it is only consistent, no. Only stable, no. If it is only consistent and stable, yeah. So this will be the correct answer. Yes, our solution always has to be solved. If you want to apply this multi-step method, it has to be consistent and stable. Okay, both condition is to be satisfied. So this is the correct answer. So option C is the correct choice. All right. Now there are few definitions of the Adam-Bashford method of order tree. Okay, and you need to find the correct answer. So so it is very easy, because here you can see the two minus sign from here, and remember this formula. This is for a higher order. This there the plus minus, there is a plus and minus alternative. Okay, so you can take the idea from here, and you will see that this is not a correct option, because all of them are plus. Here all of them are minus, and here there is an alternate plus minus sign. So option A is the correct answer. Okay. Okay. So this is another question. Identify the correct option. The implicit Euler method is an implicit linear one-step method. Yeah, so this is the correct option. This is not trapezoid, this will be trapezoid. The trapezoid is an implicit linear one-step method. True. The four-step Adam-Bashford method is an explicit linear four-step method. Yeah, we have already seen that this is true. So all A, B, C, all of these are correct option. Okay. Now I will just show a few things in the theory, then I will conclude. That is, so now, so here we are trying to find the formula of dxdt using various technique. Okay, so one such technique already know, that is the Taylor series expansion. So I will just briefly discuss about the Taylor series expansion, then the Taylor series expansion, and how to find the formula, how to find the correct formula from there, how you can derive it. You already know that, but I will just go through it once again. Then I will talk about the linear. Then I will show do a small problem regarding that. Okay. So the formula is dx dt equal to f of xt. Okay. Now I am so f of n is equivalent to f of x at Tn, comma Tn. It is f of n, and x of n is at x of Tn. Okay. Point. Now let me write down the formula. So d is equal to f of xt. So x of n plus 1, that is x of Tn plus h. So I can Taylor expand around this Tn, which will be equal to x of n, that means x of Tn, plus h into dx of n dt plus h square by 2 d square x of n d d square plus dot. Okay. Now we have dx dt equal to f of n, right? And d square x dt square n, you can see that f is a function of both x and t. Okay, so you need to expand it and use the chain rule for it. Use the chain rule, and you will finally find this as n. In indicates that it is at xn and tn. Okay, so if I go back and plug it and plug it in the formula, it will be x of n plus 1 will be equal to x of n plus h. What is this? This is f of n, right? Plus h into f of n plus h square by 2. Now you can see that it is dx dt again. So it is f of n. It will be del f del x n into f of n plus del f del t of n. So this is of order 2. And the order 1 formula is already been very familiar to you. In the last class I have solved many questions questions using this example, that is xn plus 1 equal to xn plus h of fn. This is the order 1. Alright. Now, yeah, so now this is the question. So you are provided with a formula, and which is x of n plus 1 equal to x of n plus h into a k1 plus b k2. Now k1 and k2 are provided. F of n k2 equal to f of tn plus alpha h x of n plus beta h k1. Now you need to find the values of a, b, alpha, beta, or some combinations. So it is told that finally the value of this combination and this for the final thing has to match this expression. Okay, it is told the final thing will be the accuracy of this formula will be same as this order two formula. Okay, so let's do that. So see, so what is the idea? We need to expand k2. Okay, so this is the idea. So k2 will be equal to f of n, that is f of tn, plus alpha h del f del t in at tn xn, plus beta h. So according to this term, plus beta h k1 beta h k1 del f del x n. Now k1 is f of n. Okay, so let's write that equal to fn plus alpha h del f del t n plus beta h f n into del f del x n. Okay, so now we we need to plug it in this formula k1 k2. We need to plug this in here. So if you do it carefully, you will find these expressions equal to xn plus h of n. Okay, so we can take few terms common over here. H times a plus b f of n plus h square by 2 2 alpha b del f del t of n plus 2 beta b f of n. Now what is the formula? The formula it should match this expression, right? Xn plus h of fn plus h square by 2 into this expression. Now, this this final thing has to match that formula. So you will get a plus b equal to 1, alpha b equal to half, and beta b equal to half. Now you have three equations and four unknown. So you can take b. So your a will equal be equal to 1 minus b, alpha will be equal to 1 by 2b, and beta will be 1 by 2b. Now you can change b accordingly. Okay, you can take some value, and for each value of b you will get a new formula. Okay, so so this is actually called the RK2, Rangekota of order 2. Okay, so from use changing the value of b, we will get a series of new formulas. Okay, there are some specific value for b equal to half, b equal to 0. There are some popular formula. Okay, based on this, but the whole idea is coming from this RK2, this derivation. Okay, all right. Now, so now this so far I have talked about the how to get these things from the Taylor series expansion. Now suppose I expand everything in terms of polynomial. Okay, in this fashion, a0 of n plus a1 in t plus a2 in t square. The idea is same. A2 n means a2 of tn into t square, something like that. Okay. No, no. These things are the constant and t is the variable. Okay. Here n comes because it is xn. So my the differential equation was what? Dx and dt equal to f of xt, xn tn, right? This. Okay. So now my f of xt, to get that I need to simply differentiate it. It will be a1 of n plus 2 a2 n into t. Now let me redefine the time. Let me shift the time. It will be tau equal to t minus tn. So for the explicit scheme, for the explicit method, what will be the case? It will be, if in the explicit method, if I have x, if I at n step, then I should know all the previous step fn minus 1. So it is a, suppose it is a single step explicit method. So I should know fn minus 1. So what will be fn minus 1 from this definition and this using this? So if it is tn plus 1 minus tn, then it will be h. If it is tn minus 1 minus tn, it will be minus h based on this definition. Now I will change everything to tau, and finally I will get this result a1n minus 2a2n into h, because I am shifting everything to tau. You will just do it, you will find that fn minus 1 equal to this expression. And f of n at t equal to tn, at t, f of n minus 1 is t equal to tn minus 1. So in this case, I need to use tn minus 1. You will get, in terms of tau, you will get minus h. And f of n, you need at tn, that means tau equal to 0. So f of n will be simply a1 of n. And x of n, from this formula, you can find, I need to again put tau equal to 0 here. It will be simply a0 of n. Okay. So I have a0 of n, a1 of n, so I need to find a2 of n. So a2 n will be fn minus 1 divided by 2 of n. Okay. So now if you just if you just plug it in the formula, x of tau. Now I am doing everything in terms of tau. It will be x of n, that is a0 of n, plus a1 n into tau, that is a1 n is my, I know, that is f of n tau, plus a2 n tau square, that is f of n minus f of n minus 1 by 2h times tau square. Now I need to find a value x n plus 1 because that is the goal. So it will, in place of tau I just need to put h. So it will be, if you do the calculation, you will finally get xn plus h by 2 3fn minus f of n minus 1. I hope you are familiar with this formula. Okay. And similarly, for the implicit scheme, I will not do the derivation here. I will just give you the idea. For the implicit scheme, here you need to put fn plus 1. Okay. Then it will be 2 plus a2 and h, and you need to proceed accordingly. So if you do that, you will find the formula of the trapezoidal. This formula, xn plus 1 equal to xn plus h by 2 fn plus fn plus 1. Just follow the same procedure. Okay. So now I will quickly talk about a last thing, then I will conclude. And tomorrow I will do a brief summary class for 1 hour. Yes, in that summary class I will briefly go through all the things that we have covered in this 12 session. So this is the last topic, that is the stability, right? So for explicit scheme, you need to careful about the step size you use. Okay. So if you are using explicit scheme and your step size is sufficiently large, then you will completely go to the wrong answer, because for large step size the solution is not correct. But for implicit scheme, you don't need to be careful about this age. Okay. Now from a very simple stability example, I will show you why. Okay. So this is the last topic for today. So suppose, let us take a very simple example problem. This is dx dt equal to ax, with x0 equal to x naught and a is less than 0. See, we all know what is the final solution, the analytical solution. Let us define the analytical solution by x star. X star equal to a e to the power at times x0. So it will be a decaying exponential function as a is less than 0. So x star at n, it will be equal to e to the power a in h into x0. So x star of n plus 1, it will be e to the power ah into e to the power a n h into x0 simply. So it will be e to the power ah into x star of n. Okay. So this is suppose your one equation. Now for the stability, we need to talk about error. With time, if error decreases, then the solution is stable, obviously. So, so first let's talk about the explicit Euler theorem. Explicit Euler. Okay. So the formula is xn plus 1 equal to xn plus h into f of n. So it will be, now f of n is a of h is a into h. So it will be 1 plus ah into xn. So that means xn I can write in this way, 1 plus ah whole to the power n x0, right? So now let me define the error. En equal to x star at that time minus x star. So this is the definition of the error. So En plus 1 will be, so now in place of x star n plus 1, from the first equation I can write this e to the power ah into x star of n. And in place of x n plus 1, I can write this minus of 1 plus ah x n. So I can remodify it. Okay. So I am adding one x star 1 plus ah x star n. So that means I can take common from here, minus x star n minus x of n. So I need to subtract the same amount. So it will be plus x star n e to the power h minus of 1 plus a into h. Okay. So now this is what? This is of my en. So the expression is 1 plus a h en plus x star n into e to the power h minus 1 plus h, right? So suppose this is equation 2. Now consider equation 1 and equation 2. We can write these two in a matrix form. Plus 1 start in plus 1 equal to 1 plus a h e to the power h minus 1 plus a h 0 to the power a h in x star of. Okay. Now the solution will be stable only when the, the eigenvalues of this matrix are strictly less than 1. Okay. Now use your idea. Now use your knowledge of the linear algebra thing. We have already done this. What will be the two eigenvalues? One lambda 1 will be 1 plus a h, and lambda 2 is e to the power a h. Now it is told that a is less than 0 and h is greater than 0. So e to the power a h is always less than 1. So this is already satisfied. Now I need to do mod lambda 1 should be less than 1. Okay, this condition needs to be satisfied. That means modulus of 1 plus AH has to be less than 1. This implies if you expand this, you will get AH is less than 0, less than minus 2. Now your A is negative, okay, and H is positive. So you need to take your H it is suppose that it is within this limit. If it is outside this limit, then your solution is not stable. You are going to get wrong answer. Okay, so this is the reason why in case of using explicit technique, the formula is simple, the computation is simple, but you need to take care of this step size. Okay. Now, why we generally prefer implicit scheme? Because although the formula is complicated and the calculation is also complicated. In the last class, in the last class where I have solved the implicit problem, so there I need to, in order to solve the differential equation, finally the problem ends with solving a Newton-Raphson iterative technique. But if you solve it using the explicit Euler technique, there is just a one line calculation. Okay. Now, in case of implicit Euler technique, so here I will not do the entire derivation. The idea is exactly simple. I will just write you the final matrix form that it will get. Let me write down the matrix form. So the idea of the derivation is exactly the same. Okay, I am just writing down the final matrix form. You will finally get En plus 1 x star n plus 1 equal to 1 by 1 minus AH e to the power AH minus AH given of the x star. Okay, so idea is the same. This is the matrix from, just follow the same path that I did for the last this explicit technique. You will finally come up with this answer. What are the two eigenvalues? Lambda 1 equal to 1 by 1 minus AH. Lambda 2 is equal to e to the power of AH. Now this lambda 2 is by default less than 1. We already know that. Now this modulus of lambda 1 needs to be less than 1. But what we know that AH is greater than 0, A is less than 0. So minus of AH is always greater than 0, right? So see this term 1 by 1 minus AH, and minus AH is a positive term. So as a result, we are getting some 1 by 5, 1 by 6, this kind of positive term. Okay, so which is by default less than 1. So see, whatever is the value of H, whatever is the value, that is not a problem. Whatever is the value, it will always be less than 1. Okay, so that is why the implicit scheme is unconditional, is very stable. Unlike the explicit scheme where you need to take care of the step size, in this case you do not need to take care of the step size. Okay. So similarly, in the same manner, you can try it. You can find for the trapezoidal rule, Adam's technique. For all this thing, you can find the stability of you can find the stability criteria. Okay. So that's all I have planned for today. I will share the all these notes and or obviously all the codes with you, so you can practice that and try it at your home. And we will meet in the tomorrow for the summary session, and that will be just a 1 hour session. Okay, and so good night.